All right, well, we're back here with the capacitance checker, and I got capacitors for the capacitor checker. But somebody, an astute watcher, had mentioned in the comments to check the resistors, a couple of the resistors, and the ones were right by that capacitor. So I'm going to just chop the old capacitors out before I solder them in, and I'll check those resistors. By the way, this is Tim Time Projects. I'm Tim, and this is a project. So I'm going to switch this around to see if we can get it in the frame. There we go. All right, I'll just snip those leads off. We'll check it real quick, but I'm sure there's no no voltage that stayed on there. All right, let's see. Yeah, there is no voltage. 0.02 volts. So we'll check this one as well, because I'm here. Same thing. Okay, so let's get these guys out of here. And let's see. This guy. I love this little guy. Yeah, this is easier said than done. Gee willikers. Oh, there we go. Now I'm going to pull this vacuum tube out of here. All right, looks like 47 Ks are in parallel, so that should be what, 3.5 K. So let's just see what we get from that. I'm just wondering why they did that. So that's 22K. Yeah, 21.99, so 22K. So let's see which 10% of what I say would be 24.5, right? No. 47, so 23.5. So that's still well within 10% on that one. Let's see. Here's two more. That's weird that they put them in parallel like that. This one's almost 22.3, so it's even a little bit better. All right, then I have a 33K. Looks like it's by itself back in there. If I can get back on there. I guess I can just leave that where it was. $31.25K. So what 10% of that would be, it could be 3,000, and that's within 1,075, so that's good. There we go. So I did check a bunch of the other resistors, and everything's pretty close to being in there. And I didn't expect it to be that far off. I'll tell you the truth, I really don't think this got much use. It looks pretty well taken care of, and like even around the knobs where your fingers wouldn't normally like rub, but there's no rub off on anything. The only thing I see is a scratch here. Cleaned it all up. Mark right above that scratch. Let's see. So I'll throw the new capacitors in. We're pretty happy with the resistors there, the resistor values. I threw that one capacitor in here. I'm zoomed in all the way, but that was actually 2.01 microfarads in parallel. The schematic called for 1.02 microfarads, so I had a 222, a 0.022. And I put it in, and actually that's actually lower than the what was in there when I tested. The one was a 1.017 or something, and the other was a 0.013 or something. Anyhow, it was higher than that. So I had some, when I was wiping this off, my rag was deteriorating, so I had all this little white fluffs all over everything. All right, let's fire up the soldering iron. Ow, 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 ow. And let's see. So it's with that first one, it comes over to where these guys are. So that's the thing, huh? Let me get this out of my way. You know what, I'm going to do this one first because this one is more in the way. I haven't committed these all to memory. Alright, so he goes back in. Let me clean this blob of solder out of here. I don't know if you can see it or not. It's right here. It looks like some kind of a bug. Some of it. There we go. That's what I was trying to get out of there. Alright, I believe we got it. I'll just make sure that I didn't create a problem. Nope, it all looks good. That one's a little blobby too, but I'm not too worried about that one. I cleaned off the switch contacts, used the Q-tip and some deoxit. So watch this one here. Let me see when I clean the front side of it. Right there. And the one down there. Alright, and then I'm just going to hit it with a wee little bit of deoxit to lubricate it. I'll hit them all with just a splash. Alright, now I'm just going to hit the variables. They all feel so smooth. Alright. So all I want to do is wipe down the inside of the case again. And then we'll be ready to throw that back together. There's a couple of resistors on the by the capacitors were good. And those were all on the straight wheel were good. The ones I checked, I had to kind of move things around to get the accurate reading on them. Yeah, but there's nothing at all discolored in here either, so. Alright, so let me finish with this. I'll pull this tube out here and just kind of clean around. I don't want to wipe any of the numbers off it. That's why I've been hesitant about doing that. A little bit of dampness takes that right off, but it also takes the number off. It's a 6E5, by the way. Alright, well, I wish it had a little bit more heads up when the camera's about to die, but we didn't really miss anything of excitement. So let me go get the case. I'm going to put the case back on. Scrubbed on the case too, and it all looks good, as we say. Let's see. Let's see. These are the optics. This all goes in here like so. And then it hooks into here. Like so. You think? There we go. It's in nice and good. What do I do with the? I put them over there. The little screws for this. Oh yeah, I sure did. The patented Heathkit slot screws. They're still in really nice shape. I'm not going to change them out. I usually switch these all over for Phillips. This has some kind of a, oh, like a pink paint mark on 2 spots back here. Like maybe someone was painting the house or something and did a little bit of splash on it. But here it is here. You can see the nice number, IT serial number 0392134. And there's another one of those little speckles of paint. And I'm not going to jeopardize the case just to get them off. They're almost non-existent. So let's turn the AC off. Put this in the discharge position. We're going to plug it in and see what happens. It's plugged in. Oh, and by the way, check the safety caps, and they're both good. AC is on. Nothing broke yet. Hope I have that plugged in. Yeah, there's the green eyes coming on. All right, and I got my replacement knob today. Looks very, very good. Let's see what happens when you push it on. Oh, look at that. It goes right on there, too. Okay. Have it on and running, as you can see by the lighted eye. A couple of things that I found here. Test is where you would put the component that you're going to test, capacitor, whatever you have. This will do. You can test resistance, inductance, and capacitance with it. External generators, if you want to test something with other than the 60 cycles per second comes in here, I recommend for better accuracy that you can use an external generator and pump it up to, I think they're always saying 1 kilohertz. External standard, now that's if almost like comparison. From what I gather, let's just say you have a capacitor, you don't know what the value is, you took it out. If you put a known capacitor in here, and then you put the one to be tested across test, as you change this this dial, it'll basically bring you to a point where the eye is going to change, and then you multiply or divide the numbers on here by your known standard, and that'll tell you what the value is. I mean, things like that nowadays with test equipment, crap, you don't even, think something like this. You just put a component in there and it'll tell you what it is. The main thing I would probably use this for is the capacitor checker for the voltage. So let's give that a try. Let me grab a nice pair of, actually I could just probably put it right across the terminal. Oh, let me get cables, because if I don't, I'll regret it. I really want to use for something, but I just want to see what happens. So let's see, the first thing we're going to try, let's use one of these capacitors right here. And it's rated at, I'll turn that for you, 630 volts. The highest this goes is 600, but we'll go with that. So we'll just throw it down to discharge. It's going to go with paper, other. Alright, let's turn this up to 6 gajillion volts. And now when I test for leakage, the eye is what we're going to be watching. Alright. Basically it says if it closes and then returns to the open position, it's good. You can see how quick it goes and changes. So let's discharge this one. Oh, and by the way, the bridge position is for when you want to test the other things and not go through the high voltage test. All right, let's try one of those electrolytics we took out. Electrolytic, we're going to put a plus on the plus and a minus on the minus. And these ones are 350 volts. Let's go up to 350 volts. Get this guy out of our way. Remember to watch that for an open and close real quick. Leakage. Well, it's closing. There we go. And it opened. So it took a while, but it worked. So we'll throw it on discharge. Let's check the other one. And I'm going to go get another new big electrolytic capacitor and see what we get out of them. Okay, so this guy, the plus will go here, maybe. Plus will go here. Minus will go there. All right, same deal. Watch that. Closed. It's thinking. It's thinking. I don't know. That would be maybe a leaky capacitor. That one. The other one took a good period of time, but this one's not opening back up. So I would say that that capacitor, let me see if you can see which one I'm doing here. That capacitor is leaky. Those are the two from the machine that I replaced. So let's discharge that. Let me go get another electrolytic for the new one. Here we go with a 33 at 450. So let's put this guy on the positive lead. Put this guy on the negative lead. Bend it out of the way so they don't touch each other. We'll move this up to, well, let's leave it at 350 for now. And let's be sure to watch that, the leakage. There it goes. And we'll discharge it. We'll try it at 450, the rating. And it's closing. And it's opening. So the bigger electrolytics do take a little bit of time. Let me try a smaller electrolytic. Put that on discharge. Here's 2.2 microfarad at 450 volt. So let's just see what that one does. That's 2.2. Minus goes to the minus. Plus goes to the plus. All right, let's see what happens. We're going to watch the eye. And look how quick that opens. Let's try a lower voltage one. What do I have here that's... Those are all 450s. All right, let me put this away. And I'll get one more. We have a 10 microfarad at 25. So we'll set this guy way down to 25. Right there. Put the minus on the black side and the plus on the red side. All right, get ready for it. And it doesn't even, it's like the other one. See how quick that is. Okay. Back on discharge. Yeah, even though it says discharge and I did check the other ones with the voltmeter. I'm still leery about putting my fingers across those terminals, even though it says discharge. It's probably like a little ha-ha thinking, sorry, it doesn't really do anything. Okay. So let's try... Let's see if we can figure out how to just measure the capacitance of a capacitor. I think you just leave that down there. We'll put this up on bridge. I'm going to put negative to negative, positive to positive. And what do we think this is? 10 microfarad. Which one of these is capacitance? This one. I don't think you'd have to tell it electrolytic. Oh, there we go. You see it? It's opening up. And its maximum open is almost exactly on the 10 scale. If you follow the capacitor around to right there, it says 10, and we're on the times 1, so 10 times 1. So hey, nice job. Let's see if this matters. It changes a little bit. All right, let's try a different type of capacitor. Let's try one of these. These were 40. Let me get the one with the better lead on it. These were 40. So I'm thinking when this dial gets up to around here, or we could do the times. No, that won't work. So we'll have to get it all the way up there. Look, right on the 40 almost exactly. Nice. Nice. Okay, that's enough with the electrolytics, so let's get them out of the way. $254, so that'd be... Let's see. I have to look their little sheet up. Should be 2.5 with some zeros or something. If I still have it. Oh, look at this. I got a bunch of capacitors from them, and they give you this little cheat sheet on the back. It tells you, so I'm looking for a 254. There's 253. 254 is going to be a 0.25 microfarad. So we'll put this at the 0.0 or is it 0.01? Let's see, do we have a, well, we can leave that there again. We'll just leave it on the times 1 and see what happens. Should be, what did I say, 0.25, right? So that would be right around there. Let's see if we put it on paper, if it matters. Wow. Really touchy. So this is showing about 0.22, but close enough. Close enough. Let's see what this says it is. That's saying about 0.22. Well, that hasn't been calibrated or anything. And well, this is saying this is 251 nanofarads, so move it over 3 places. 1, 2, 3. It's 0.25 microfarad. So I don't think I have an inductor around here. Yeah, so when you do the resistors, you can do those, and the capacitors this. But when you do inductors, you have to use external standard because it doesn't have any comparator to go against. So you have to put something in the external standard for inductors. You know what that is? Power factor, there's the crazy multiplier that tells you how bad the capacitor is getting. Let me see if we can get some type of a reading on that. You might be asking yourself, why didn't I do an alignment to it? Well, I guess I could. For me, it was close enough to working pretty darn good, and for what I'm going to be using it for. I guess if I want to go and do an alignment a little bit later on, I'll probably make another video, because you can't obviously calibrate it like all those tools, but it worked. So I did not do an alignment to it, but I was happy with the way it worked out. So I just wanted to put that note in there. You can measure transformer turns with this. I have a feeling this was one of those things that back in the day, somebody that really learned how to use it, it was a very valuable tool. Power factor is the measure of energy loss in an imperfect capacitor. Alright, so what they tell you is adjust the balance control. Which I would imagine is what they call that. Set the type to either minlytic or electrolytic. Ours is an electrolytic, depending on the type. Minlytics are electrolytics that are usually encased in ceramic or plastic and are completely sealed, just so you know. The balance control and the power factor control for the widest opening of the eye tube, so I'm really excited about it. So that's it, and it's all put back together. So thanks for watching, and I hope it was fun for you. Power off.